Good afternoon, everyone, and thank you for joining this webinar brought to you by IEEE Computer Society Bangalore chapter. Myself, Vishwas, the chair of the Computer Society, and our secretary Anand will be with you for the next 1 hour 15 minutes. And today's talk is a joint webinar series 2020 between IEEE Computer Society and WITS Goa Center for Artificial Intelligence Research. So today's talk will be delivered by Dr. Asif Iqbal from IIT Patna, and the topic is teaching conversational machines with human effects. And we have had a lot of webinars in the last couple of months. I hope you have had a chance to go through them or even attend our YouTube channel where we host them. So I would like to thank Dr. Asif Iqbal from on the behalf of the Execom of the Computer Society Bangalore chapter for agreeing to deliver this webinar today. He'll be talking about more on the NLP of the machine learning with human effects. More on that directly from Asif, and he's currently he's an associate professor in the Department of Computer Science and Engineering at IIT Patna, and his research areas include NLP, information extraction, text mining, and machine learning. And he has published prolifically over the last 12 years in all the leading journals and conferences. And he's also been awarded many research grants from both industry and academia. So a little bit about the Computer Society Bangalore chapter. We've been one of the very active chapters within the Bangalore section, and also globally we've been recognized for our efforts. And to all the participants, if you want to join Computer Society and contribute to the technical activities of our chapter, or also be a volunteer and deliver talks, please feel free to contact us through these channels. This is our website. You can also email us here and also follow us on Instagram, Twitter, Facebook, or LinkedIn. So all the updates are here, both the upcoming events as well as the past events, and all the recordings of the webinars are available on YouTube as well. So without much ado, I hand over the virtual desk to Dr. Asif Iqbal for his talk and a couple of announcements from Anand to follow. Thank you.
Yeah, so all participants, please note that you are muted on entry and kindly stay muted unless you are in the Q&A session and you are asking some question. Also, try to just note that the Q&A tab has been disabled and you have to post your questions in the chat window. So kindly, if someone could quickly type something there just to verify that we are able to chat.
Yeah, Anand, I just did, and I think Madhusudan also did, so I think it works.
That came back in the Q&A tab, so I just wanted to verify. Yeah, thank you, thank you. Yeah, so over to you, Dr. Asif.
Okay. So
You are a presenter now.
now is visible, right?
Yeah, it is visible. It is
Very-
visible. It is visible.
Okay. Okay. So good afternoon to all of you. I must thank IEEE um, Computer Society of Bangalore, Dr. Vishwas, his team, and Pratik and the organizing committee for giving me an opportunity to talk with you. So I'll be talking about some of the recent research that we have been doing related to the conversational artificial intelligence. This is nowadays one of the hot topics, and I will mainly talk about some of the very recent research that I have been doing with my scholars. So before beginning, so this is a outline of my talk. I will briefly introduce conversational AI. Then I'll talk about what we mean by grounded conversations, then affected conversations. Then I'll talk about how to introduce the courteousness and the politeness, sentiment, emotion, all these affect values into the conversational agents. Personalization is very important in nowadays conversational artificial intelligence. So I'll talk about what we have been doing for personalization. And another interesting direction is the multimodality, that rather than only text as an input, if the input is coming from the diverse sources, like text, audio, video, image, etc., then how a particular conversational agent should work. Then summary and conclude. And at the end, if I have some time, I will just give you a very brief overview of what our research group at IIT Patna, that AI, NLP, and machine learning has been doing. So, the conversational AI, you all must be knowing that artificial intelligence is nowadays one of the very hot topic and is the most discussed technology among the researchers, consumers, the enterprises today. And conversational AI powered by the advanced machine learning and natural language processing is in the center of AI revolutions during the last few years. You know, what are the examples of conversational AI systems? You have been using it every day. For example, there can be the phone-based personal assistant like Siri, Cortana, Google now. Or let's say you want to talk to your car, communicating with robots, clinical uses for mental health, chatting for fun, etc. All these come under the conversational artificial intelligence systems. And the most simplest form of conversational system nowadays is the chatbot. Now, let's see that what is the impact of chatbot in nowadays. So there is a recent report, the Chatbot report 2019, that shows the global trends and analysis at the Chatbot magazine platform. It shows that by 2020, the 80% of the enterprises will use chatbots. By 2022, most of the banks will automate up to 90% of their activities that is related to the customer interactions. And according to research also, it shows by 2021, there will be $4.5 billion will be invested into developing the channel. So from these statistics, you can easily get an idea how this particular discipline that we call as a conversational artificial intelligence has become immensely attractive, popular, and useful in every sector. So now, if you look into the history, that what we mean by the channel. So it started actually long back in 1960 with the experiment of Elijah at MIT. Okay? So, but nowadays in today's Chatbot, what is the difference with whatever was introduced in 1960? There has been a phenomenal changes since 1960. Okay? And nowadays, as I showed you, it has become a full-blown industry. Nowadays, chatbot is not simply like asking your bot or asking your agent to perform to play a song or booking some railway ticket or airline ticket. These are all are concerned with the knowledge-based system. Knowledge-based system means you have the set of predefined answers, you pass the query, and then retrieve the possible responses. That actually that we have been doing since the last decades, 2 3 decades. But nowadays, what is the most important characteristics that a chatbot should have? So nowadays, chatbot to say that it should mimic the dynamics of human conversations. Like when two humans communicate with each other, there are a lot of if you closely look into this conversation, you'll find that the conversation is not just like a mechanical conversation, right? So there are a lot of affects involved into, a lot of sentiment changes, a lot of emotion changes. Let's say if I talk to my friend and when my friend say that okay, he has his days is not going good because something wrong has happened with him, then I understand his feelings, and as a friend I should console him. Now let's say if you replace your friend by a bot, can a bot do the similar thing for you? Can a bot understand your feelings and can it respond to you accordingly so that you feel more comfortable and you keep on conversing with your bot for a long and longer period. So that is how particularly this talk concerns me. So this particular dynamics of human conversations you have to mix. But how can you do that? What are the techniques? We can do it by generating very engaging responses that will be very pleasant to the communicators, and that cannot be done so easily. It can be only done through deep language understanding and meditation. It should understand the user's need, context, and memory. It should be able to understand, respond with personalizations is an important concept, sentimental values, and emotional analysis. The bot should have the important characteristics like human, for example, the specificity and the empathy. So, how can we achieve all these things? That means we need the advanced concept of NLP and learning system that merely does not talk about understand the meaning of a particular sentence, but it should understand the meaning of the whole context. Okay? So that is very important. So what you have to do is that you have to empower AI, artificial intelligence, for human-like conversation. And Facebook AI has identified 5 important properties for that. Like how can you make a chatbot to behave like a human being? So one of the characteristics is the consistency, the specificity. Another one is the empathy that I am going to talk about. For example, it should understand the speaker's sentiment, emotions, and it should respond accordingly. It should be knowledgeable, and also it should understand the multimodal inputs. So it should have the capability of multimodal understanding. So now let's see that how can we achieve these properties. So in today's talk, I will be mainly talking about this part, that is affect awareness, okay, and the knowledgeability also I will be playing to this. How can we make it knowledgeable? And also finally, I will see that if I get a chance, that how the message can be taught to understand the multiple inputs. So now historically, if we go to this chatbot and the conversational agent, so there are 2 types of parallel agents. One is that open chit chat agent. Okay, there you can ask any kind of questions, and it is not very task oriented. Okay, that means there is no need to define very fixed tasks, and for that task only you are interacting. That is not the case. And the other one is the goal-driven dialogue agent, so task-oriented dialogue agents, where you have many, for example, you have predefined tasks. Let's say you want to design a chatbot for railway reservations. Then the chatbot should be capable to work for all the queries related to the railways. If you want to deal with, for example, healthcare, then healthcare is your task, and for that you have to build all kinds of conversations. You have to enable it to understand all kinds of healthcare related activities. So you can see that if it is an open domain, then the task will be more difficult. But if it is task oriented, then there is a kind of fixed task. So within that task only, the conversation will go, and probably you can build an effective model to handle these conversations. But if it is open domain, then there is a lot of challenges because topic will keep on changing very frequently. Okay? So now let's see that what are the modules in a task-oriented conversational AI. So this figure shows the typical model. If it is a let's say speech-to-speech kind of processing you are doing, then there should be a audio, there should be you speak something, there should be an ASR, automatic speech recognition. Then that should be converted into the text. then there should be a natural language understanding, then that should be a semantics. Okay? You have to understand there is an important concept of dialogue management, then there is a natural language generations, and finally you do the speech synthesis, text-to-text speech synthesis, and finally again you respond. This is the typical scenario of any chatbot. Now this NLE, the dialogue management, and NLG are the core component of dialogue, the whole dialogue systems. Now, in my talk today, I am more concentrating on the natural language generation. I'm not, I will not discuss on NLE, which is very important task also, and I'm not also going to talk about dialogue. Now, let's see what we mean by the natural language generations. It is one of the critical components as I showed you, and it is the goal of natural language generation is to generate the natural language sentences, okay, to satisfy the user queries. Often, this is performed in two steps. One is the content planning and the sentence realization. Because in the figure, you might have noticed that after dialogue done is built, the natural language generation comes. Now, the task of the content planning is handled by the dialogue manager. Okay? And the sentence realizations is the task of the natural language generators. Now, if you say by the content planning that what to say, for example, in the task, what to say, that means you have many predefined answers, and then you devise a mechanism to understand what to say, and eventually you come up with one possible sort of answers, and it goes to the NLG. And natural language generation now decides that how to generate that answers, okay, how to produce that answer to the speaker, to the end users. For example, if the user asks, "Look, flight from Kolkata to Delhi," your bot will be responding like this: "Can you please specify the date of travel?" So this is expected from a natural language generation system. Now we see that now if we have a conversational AI agent, particularly in the natural language generation's perspective, then what we mean by knowledge and affect grounding. Okay? So knowledge grounding means when we generate the response, at that time we have to exploit the background knowledge that is available to us. And that background knowledge will be relevant to the conversations that is going on. So I will show you an example. And why it is important? This is important because when the bot will respond, that response will be not out of the track. If you incorporate some external knowledge, then it will be more knowledge highway, it will be more knowledge bound. Okay? So as an example, if you see this, this is the review of a restaurant, popular restaurant in Patna, which is named as Biryani Mahal. Now, there are two reviews you can see. Two users have written. Now, let's say there is a bot, and the user is saying that going to Biryani Mahal tonight. Now, any neural model means in this case, any system that is developed of neural network, it might say that you have a great time. Now, if you say to your friend, for example, going to Biryani Mahal tonight, then the human will be more information oriented. He or she might tell you that okay, you love it. It serves the best biryani in Patna. Okay? So that means you can see this last part that it serves the best biryani in Patna is an additional information. How you are getting this additional information? If you look into the reviews that is written by the user, so there is a mention. For example, the first person has mentioned the best biryani in Patna. So these informations we have captured from this given knowledge base. You can say this is your knowledge base, background knowledge. This information you are getting from that, and that you are incorporating when you are responding. Now, let's say if a bot responds like this human by incorporating the all the relevant informations from the user reviews, then you see that these conversations between the agent and the users will be more engaging. Okay, will be more engaging because it's saying that the best biryani in Patna. So this actually we expect from a chatbot. So this particular example shows that what actually we expect from a knowledge grounded conversations. And also there is a you love it, so you see that there is a positive affect, positive sentiment expressed. So this response, if your bot would have been responded like the human, it would have been more engaging and more informative to a particular user who is trying to choose one of the restaurants. Okay. Now let's say this is knowledge grounding. Now let's say what we mean by the affect grounding. In case of affect grounding, we want to introduce the human affects. So what we mean by the human affect? That means you have to understand from the conversations the implied feeling of the humans or the speakers, and then bot has to understand it and bot has to respond accordingly. And this is an extremely challenging task because human sentiment and emotion are not fixed. There is no any objective measure by which you can measure the sentiment or the emotion. It is completely subjective, right? So what you have to do is that when you generate the response, at the same time you have to generate syntactically correct response, but at the same time you have to also introduce the human affects in the form of sentiment and emotions. Now there are two ways of doing it. One we call it as the affect controlled, and the another way is the affect IO. Okay? So affect control means, let's say you ask the bot in advance that, okay, I want to generate a response which will have a positive sentiment, or let's say which will have a sad emotions, for example. Then bot will learn, adapt it accordingly. The other thing is more difficult, which is affect IO. There you have to learn from the human conversation. So what is your mood? And accordingly, bot has to adapt itself and then generate the response accordingly. So one is the controlling by affect, the other one is the understanding the affects from the human conversations and then generating the responses. To give you an example, if you look into this, this is taken from a very important data set, empathetic dialogue data, which is very recently introduced, and it is very useful data set for dialogue generations, those who actually work for affect grounded dialogue generations. Let's say if the speaker is saying like this, I finally got promoted today at work. Now, if the listener says that, why would anyone promote you? Then you see that this response, the crossed out response, is syntactically correct and it is also relevant because you can say like this. But if you say like this, then the speakers will not be happy, right? Because the speakers is sharing his achievement with you, and on the other hand, you are simply discouraging the speakers, or you are not actually understanding his or her feeling. But now, let's say if the response is like this, if the response is congrats, that is great. Then what will happen if the bot responds like this? Then the speakers will be happy because uh, the speaker will understand that, okay, this agent is of the, let's say in case of agent, if it is a friend, if this is by friend A, for example, the cross A, and friend B is the congress that's paid, then obviously speaker will be more associated with friend B than friend A because your friend B is appreciating, acknowledging the underlying feeling of accomplishment of the speakers. So this particular example shows that what actually we expect from a affect aware conversational AI systems. Now, all these are the very recent problem, and none of the tasks is very easy. I'll show you very briefly. I will not go into very technical details, but I'll show you that how can we make a particular system or conversational AI system that will understand the knowledge, that means it will be knowledge grounded as well as it will be emotionally controlled. What actually we do here? It is emotion and knowledge control response generators. It is useful for multi-turn conversations, and it should use the relevant knowledge and emotion. To formulate this problem, let's say we have a set of user occurrences of multi-turn conversations. For every occurrence in the data set that we have used, there is a knowledge base denoted by BK, and there is an emotion level. Now, what is the goal? Given a particular user occurrence, you know all the previous conversational history, you know the knowledge base associated with it, you also know the emotion of the previous conversations, and then you generate a response that will be affect grounded, or in this case, affect is the emotions grounded as well as the knowledge. That was the original task. Why it is important? Because now you have understood that knowledge grounding is important because it associates the relevant topics, the entities, the relevant information, so the relations that is mentioned into the external knowledge sources, and capturing the effective informations. Also, you have understood that it generates more fulfilling, intelligent, and especially engaging responses. Now, in our case, what we have done is that we develop a deep learning based framework based on the recent transformer neural network and the generative adversarial network. Okay? So how it works, let's look into this particular architectures. This is the incremental transformer model where you have the user utterances like the previous two utterances, UK minus 1, UK minus 2, and the current utterance. And then there will be self-attended attended uh, neural network, for example. In this case, that means BK minus 2, BK minus 1, and BK are all the knowledge base associated with these occurrences. So we design we model it using a transformer model, and then we have both decoders. So decoder will generate the response. One is the primary decoder, then the secondary. So this particular part, the encoder decoder, is this transformer, and then two decoders form the generator. Okay, so it will take primary decoder will take the self-attended representations of the knowledge base from the occurrence A. It will take into account the output from the last incremental transformer network, pass it to the primary decoder. The output of the primary decoder will again pass to the secondary decoder. It will further refine the responses. And then there are two discriminators. One is the emotion discriminators, and then the knowledge discriminator. The emotion discriminator decides that the generated response that is coming from the secondary decoder, how much it is relevant to the emotion of the ground truth response, because always the generator will try to generate a response that will be very closer to the underlying emotions, and the discriminator task will to discriminate those, right? That is the discriminator. In case of knowledge discriminator, it will always try to see that how different is the generated response, how different is the generated response from the underlying knowledge base. Okay. So from this we had done an experiment with a open domain conversation datasets. Okay. So open domain means the length of the conversation is not very large, and each occurrence was associated with the knowledge from the different domains. Okay. And also, its occurrence was associated with 8 different emotion levels, like angry, disgusted, fearful, sad, happy, surprised, curious to be dive deeper, and the and then we generated these responses. So we generated this, you see that this shows the statistics, the total number of conversations, average number of times per conversations, average length of the utterance, etc. Okay. So now let's look into this, how the data set looks like. So this shows an example. So you can see that agent 1 and agent 2, there are conversation going on, but the emotion associated with the conversations, and also there are the knowledge base languages. The knowledge base is basically the Wikipedia articles related to the conversations. Now, as I mentioned in my previous example from that restaurant, here also you see that when the introduction is going on and the agent is responding, it makes use of this background knowledge. Like, like for example, the agent 2, the response is like this: the Google is reading the alphabet this. So this particular message, this particular information, you are only getting from the background. However, if your response is like this, yes, you are absolutely correct. So this response you are giving with respect to this, okay, with respect to the utterance of agent 1, then you can see this does not convey much meaning. Okay? That it does not incorporate useful information. But if your response is like this, then it is more bounded towards the knowledge base. Okay. So then we had different models, for example, sequence to sequence models, transformer, and the various ablation studies we have done. And then finally, we had evaluated how good is our model. So for any natural language generation system, when we try to evaluate, there are two types of evaluation metric. One is the automated evaluation metric and the human evaluation, we call it human evaluation. For automatic evaluation metric, there will be blue, perplexity, the n-gram diversity. Then for human, it will be fluency, the adequacy, the knowledge relevance, and the emotional content. And then the fluency measures the grammatical correctness, adequacy, or whether it is contextually relevant response. Knowledge relevance checks whether the response that you are generating, whether it coincides or conforms with the background knowledge, and then whether the emotional content is properly reflected. So these are the different evaluation metrics that we have used for evaluating our model, and you can see that this is the performance of our proposed model. So it shows that in terms of perplexity, blue, or other evaluation metrics, our model is doing well. So now I am moving towards the another interesting work that we have done in the same time. That is, yes. So uh, so it shows that this paper was published in April 2019. Okay. So what we did here is that we tried to design a intelligent conversational AI agent that transform a generic chatbot response into the courteous phrases. That means this particular concept is very useful when you are dealing with a customer. So let's say the customer care, you always need that if the customer care is not very empathetic to our demand or to our problem, then actually you may that particular service you may not take up, or you need to disconnect with the particular service. So from the business point of view, the customer care plays an important role. Now let's say if the customer care is managed by a bot, then what kind of important characteristics a bot should have? So it should understand the user's feeling and understand the user's problem, And when it responds, it should respond empathetically. So in this particular work, which is very interesting, we try to incorporate the politeness or the courteousness into the system. Okay? And its main purpose is to increase the user satisfaction and to build the customer relations. So now let's see what are the challenges to this. Um, there was no availability of the data when we model the courteous behaviors. So at that point, when we started this work, there was no data available. So we had to create our own data. Now, when we try to create the data from the politeness, we saw that the annotation of data was extremely challenging because courteousness or politeness varies across the different regions, across the cultures, across the different companies, across different service providers. So there is no universal way to introduce the politeness of the courteousness. And politeness and courteousness are also heavily linked to the emotions. Okay? So, for example, if the customer is angry, the system needs to pacify and apologize. If they are happy, then the agent should appreciate. And these characteristics we want to incorporate into the conversational AI. And if we are able to successfully do that, then the interactions between the customer pairs and the humans or the users will be more engaging. And that will actually make this, so for example, that will make the users more satisfied. And so the users will keep on engaging with the particular service or will take up the particular product for a longer period of time. So now what we do here in this case, as I mentioned, there is no data, so we have to create our data by ourselves that has both generic response data as well as equivalent politeness data. And we build a kind of model based on reinforcement learning and pointer generator neural network that should be able to generate contextually relevant and emotionally aware responses. Now let's see that historically, when did we introduce these politeness? The politeness, this courteousness is coming from the theory of politeness that was introduced in 1987 by Brown and Lewis. Okay? So the politeness, it shows the politeness in one's attitude. Courtesy denotes the respectful act. For example, if you go to a restaurant and if you find something you want, and if you complain about the bad meal, and if you are kicked out, then it is not a sign of the politeness. Rather, the common courtesy will be that the manager can apologize to you, and then if you are lucky, you can get a free dinner. So that kind of politeness you want to introduce. Now let us see that in case of customer care system, what are the politeness? Okay. One is this, for example, the generic, the courteous, and the behaviors. For example, we show here the generic response. If the generic response is like this, for example, how can we help? For example, the customer was facing some problem, and the bot is responding like this, so how can we help? Rather than responding like this, if the response is like this, let's say in the middle column, if you see that, okay, help has arrived, we are sorry to see that you are having trouble, how can we help? So now we see that the particular customer care is apologizing to the customer for the problem. And if this response comes to the user, then the user will be more satisfied. Okay, from this. Now, if you say that, can you send us a screenshot of what you are seeing? Another example. Rather than saying that, if the response is like this, in the middle one and so on, then it will be more satisfying. Then there is an example of assurance. Okay? Let's say there is a problem going on, and the the response is like this. We want to help, let's discuss it. So it becomes, you are assuring the users, the speakers. So that becomes more engaging. Then empathetic, okay. So there will be the empathy, and also there can be the appreciations. So in the following slides, again, I have shown all these examples individually. But from these examples, probably you have understood that what actually you are expecting from a bot, what kind of responses you are expecting. Okay? So I can skip the slides. So as I mentioned that there was no data. So we get some data of Twitter conversations from the travel that talks about the interaction between the different customers and the professional customer care agents. But these data were not relevant for generating the polite responses or courteous responses. Okay, this was the generic conversation. So we had to create the data for generating the courteous responses for our engine. So we did a lot of processing, we did segmentation, we applied clustering, and then we annotate the data into different for our particular experiments. So now as you can see that there are for the training there are more than 140,000 conversations in the training validation and test. And what our baseline model is, the baseline model is a hierarchical encoder decoder where this particular left part encodes the dialogue utterances from the contextual history. Okay? And from this history, we are uh, encoding it in the last or hidden state representing that particular utterance. And then hierarchically we feed them one after other. And at the end, we generate the whole conversational context vectors. Now, this whole conversational context vectors, you see that it passed to the decoder side. And what it does to the decoder side? So you can see that in the right part, there is a generic response, and from that you wanted to generate a polite response. So pass the encoder generic response. It gives the HT, okay, that hidden state, and then we have a decoded response. Then in case of process methodology, what we have done here in this case that you can see that we generate the conversational context vector. We also get the emotions expressed in that particular utterance. We pass these to the decoder to generate the final response. But we also apply the attention, okay, here, and there is a kind of reinforced learning framework. So this Pgen is the probability that indicates, okay, that controls basically that how much we have to copy from this input utterance to generate the final response, and how much we have to generate from the vocabulary. That means copying something from this input to the output is just a copy mechanism. And adding something new from the vocabulary distributions is just a kind of adding some new information. So this model actually we have developed, and this paper is available. You can see if you want to know more details. And then we evaluated again using the set of metrics, content preservations, for example, whether the content is properly preserved, emotional accuracy, etc. And we have the quite convincing results. And this is one of the very interesting works that we have done in recent time. Now let's move towards another interesting task where now we have introduced the personalized information. So far we have seen how to introduce the courteousness, how to introduce the emotion, how to introduce the knowledge. Now let's see what we mean by the personalization. In today's world, the personalization is very important. For example, let's say in the Facebook, if you want to talk to your people, so who is your native? So at first we try to know the profile of any specific person. So if we see that okay, my choices and the choices of the other people have there are some similarity, then we keep on conversing on different topics. That always happens. Now, in case of human-to-human communication, which are human-to-machine communications, so what the chatbot wants, like the human-to-human communication, can we mimic this same behavior into the chatbot or the conversational AI? Idea will be that because if you have the personality information of the person on the other side, then it increases the consistency, the specificity, the trust, and also the confidence. Because if you know the other person's profile, then you are only confident. It builds the trust. Okay? So because of that reason, the personal informations of the speakers are very important for making a meaningful conversations. And this personality also is not unique because personality can be from one person to the other person, depending upon the different emotions. Let's look into this particular example. In person 1, for example, in person 2, if you see that there is some personal information about two different persons, and then those persons are conversing with each other. Now, let's say if person 2, rather than responding like this, I don't like carrots, I throw them away. So, these background information at first you have to supply, and then based on this background information, they show an interest in communication, and then they are communicating. So, this particular part is the communication is going on in this context. Now, let's say if the response is like this to this particular example, hi, I work as a government cook, rather than if you say like this, rather than responding like this, if the response is like that, it is a great job, but I don't like carrots and throw them away, then you see that this becomes more engaging, it is more emotionally aware. Okay, it is it has a happy undertone and it satisfies the user one, the person one. So this response would be more interesting, more engaging, uh, rather than this particular response that is shown below. So this personalization information is we wanted to incorporate into the conversational AI. So we developed two techniques. In the first case is a traditional encoder-decoder framework, and we directly supply the emotion to the decoder. In the second case, we have a generative adversarial network again, and then we have a interactive discriminators to make the responses more personalized and empathic. So this is the architectural diagram. You can see that the left part, we have the utterances. Utterances are encoded. Then we will have the self-attended utterance representations. Then we have the self-attended utterance representation, the personal aware attentions. Okay, this personal aware attention says that given this particular input utterance, so which person specific information is more aligned to this because the persons are sharing many of these personal profiles. Now, if you ask a questions, for example, and then you have to know that which specific profile information is best fitting to it, okay? And then finally you generate the response and include into the decoders. Okay? The second architecture is based on generative adversarial network. There will be a dialogue context. There will be sentence will be encoded. There will be emotion level encoding, and there will be a after hierarchical encoding, and we have a conversational context. Now there is a memory network that stores all the personalized information. Okay, this memory network is very important. Memory network tells you that given an input utterance, that this particular person information is more relevant to with respect to the user utterance. We concatenate the context history, the current input utterance, the person information, pass it to the decoder, generate the response. And then we have three different discriminators: semantic discriminator, personal discriminator, empathetic discriminator, etc. What semantic discriminator does, it checks how different is the generated response from the user response. Personal discriminator checks whether the generated response is consistent with the personal information, and the empathetic discriminator verifies that how whether the implied emotions is uh, also generated through this particular generated response. That means the ground truth emotions and the generated response emotions should be closer to each other. Then we had used a data set that is CONV-A2 that has 7688 dialogues, but it was not emotionally tagged. So we have followed a semi-supervised model to annotate each utterance of these dialogue datasets with the emotions. And there are 32 fine-grained emotions, not only 6 or 8 emotions. Okay. And then we created a model which is BART-based model. And also we evaluated our system output in terms of, again, automated evaluation metric, the human evaluation metric like PNC, the personal consistency. Then the personal consistency checks whether the generated response is at par with the speaker's informations or not, and then the emotions. Finally, you can see that we have these values like complexity, you, the rules, and then the emotional accuracy. In terms of human evaluations also, you can see that there are different metrics like PNC, the emotions, and the personal consistency. So probably I can skip this result. So we got the convincing result in terms of both automated evaluations and the human evaluation. Also, there are some examples are shown here. So these are the ground truth response. These are the personalized evaluation. There is a dialogue there. And the final column shows the responses generated by our different models. And these are our different models. PPGAN, HID, plus etc. Okay? And this shows that our generative responses are of high quality, it is person specific, and also it is more interactive. Okay, I think I don't have much time, so I will go through this. Now, the last important work that we have recently done now, and it is accepted in IEEE transaction on effective computing. Okay. So one is that sentiment and emotion are two closely related problems. For example, if you see that positive is a sentiment, negative is a sentiment, joy is a emotion, disgust is another emotion, okay? And this actually uh, mm, this joy, you can see this is a emotional state. So you can see from these values that sentiment and emotion are two closely related problems. So what we have done is that so far we have considered in our work, in one work we have considered the emotion, then we have considered the politeness, and also in the last one we have considered the personalization and the emotional language. Now, is there any influence of sentiment and emotion both in dialogue generations? And also in the diverse modalities, like the text, the video, and the audio, then what will happen to this? Okay. Now, let's see why it is important. Why sentiment multimodality is important from this particular topic. Okay? Let's say thanks for putting me on hold. I have all the time in the world. Now, the sentiment is negative here. You can see clearly. If only text is available in this case, then it is very hard to infer whether it is negative or sarcastic. Okay? What kind of thanks for putting me on hold? For you are thanking. That means it have a positive tone also. But actually, this is not positive. It is mentioned in a negative sense. That probably you cannot understand only from the written text. You can understand it through the acoustics features, like from the audio is available. From the visual features, if the video is available. Let's say when the speaker is talking about, if that facial expression is available to us, whether the person is talking about, whether the audio is available to us, the intensity, the variation in the pitch, the tone, etc. is available to us, then you see that it can easily, with the help of acoustic features and the visual input, we can get an idea that this particular utterance has a negative orientations, negative sentiment orientations. So this shows how multimodality helps in sentimental emotion detections. Now again, our contribution in this case, there was no such data available for these particular tasks because all the works are very new, and for multimodality domain, the emotion and sentiment control dialogue generation has not happened. Okay? So we had to create our data set by ourselves. We had collected, the data set looks like this. So there is a conversation going on, there are both sentiment and emotions. Okay? We collected data from 10 famous TV shows, okay, which has 1258 episodes spanning across 746 hours. We collected the data from the various sources. Then we have data set statistics of every TV show. For example, that is shown here. I can so the data I would like to mention that the data was not annotated with neither with either emotion or the setting. So again, we follow a kind of semi-supervised approach. We have the small amount of label data. We label it manually, and then we use it to further annotate the remaining data sets with these 8 different emotions: joy, sadness, anger, fear, surprise, disgust, etc. Okay, so we had annotated 2000 utterances, and then we build a kind of CNN by LSTM based text-based classifications, and there is a state-of-the-art model, dialogue RNN, that also we have used. Also, we have used a BART-based model, designed a BART-based classifier to classify these particular utterances into the emotion and the setting. So this is the data set statistics. There are 40,322 training set and the test set and the validation set. And now, after doing that, how do you generate the responses? So this is the again for encoding the utterances at both the multimodality level using the ResNet we had used for the video processing, BGG we have used for the audio processing, then we have the text processing through STM. We encode it, and then we generate a context encode around that. Then we have utterance 2, we have text, video, and audio, okay, and then we have created like this. All utterances in the context are encoded with respect to from their audio, video, and the text. And finally, we developed a conditional variational autoencoder. And there are, you can see that there is a multimodal encoder that I have shown that encodes the text, audio, and video through bilateral and the context. We have the sentiment values, we have the sentiment embedding, the emotion embedding. We concatenate them together. We also have an utterance encoder. Okay? Then we have two networks. One is that prior network and recognition network. And you can see that the network incorporates the sentiment, emotion, and multimodal, and the encoded information coming from the multimodal sources, and then we pass it through the, we generate the latent variable jet, and finally we decode it. The decoders. So we evaluate again using various matrices like perplexity, sentiment accuracy, emotion accuracy, etc. And we have seen very convincing result with respect to both human as well as the automated evaluation metrics. Okay, for example, fluency, if you see, it is in the range of, let's say, most of the cases it is in the range of 46.8. So for fluency 2, that's a very good fluency. For sentiment, we have 64.6. So these are all the good values with respect to the intelligence. So this kind of responses we are able to generate. Okay, so you know we had all this code stuff in this length, and then we are generating this response, and this is going on. Okay, one after the other. So some more examples I have shown here, that what kind of examples we are creating based on the emotion and the sentiment values. So this shows that the responses preserve both the sentiment and the emotions. For example, in the last case, you can see the surprise and negative both. It is saying that, oh my God, I am shocked by the sound coming from the room. So this is a kind of, it incorporates both the surprise emotion value as well as the negative side. Now to summarize and conclude, in summary, we can say that human affects plays an important role for human-like conversational systems. Courteousness, politeness is very important for many sectors like retail, customer care, etc. Personalization is very important. Emotional awareness is very important. Incorporating knowledge base, background knowledge makes the responses more context aware and more aware about the background knowledge. Okay? It is also true that the background knowledge and emotions convey the better context aware, engaging in human-like responses. And also, we have seen that if we have both the audio and video along with the text, then we can generate a better dialogue systems. So with that, maybe I don't have much time, so to talk about our research group. But anyway, so we are doing a project with Conversational AI. For example, we are building a chatbot named Saber, okay, for the three domains. It is a multilingual chatbot, and this is an PA Government of India project. And we have already built it for the railway domain. Now we are targeting for the healthcare and the judiciary in many India languages. We also do some research on different groups. For example, Accenture we do for goal-oriented conversations with some research. We are doing some research on this area, and also we are working extensively on the different parts of natural language understanding, dialogue management, and natural language generations, and also the experiment of the conversational AI systems. So these some of the publications I have shown. So now probably I can take some questions. So thank you for your attention. So if you have any questions, so now you can ask me.
Yeah, participants, if you have any questions, you can either post them in the chat window uh, or you can ask the questions.
So you can hear me, right?
Yeah.
Okay. Thank you, Asif. This was a wonderful talk, and very happy that the Indian language chatbot is also being looked at. So you're a direct participant in that program, or is it run privately, or how is it done?
Which one? Hello?
Uh, the Indian language chatbot that you mentioned the last
Yes.
slide.
So in the Indian language, what we have done is that we had created the conversational by at first we create minimal amount of conversation, and then we created a prototype bot, and then we requested our students and their other communities to contribute, and through that process we have created the data for this Indian language. Particularly, we generated at first for English, and
Okay.
then we have translated into the Indian languages. There are some translation inaccuracies, but those we have seen that the quality of the output is still acceptable. In
I see.
parallel, also we are preparing the data by engaging the different users in the conversations, and we are gathering the data day after day. That is the process.
Okay. And how many languages are currently supported?
Uh, it is English, Hindi, Bengali, Telugu,
Okay.
and also the code mixed Hindi and English. English. Okay.
Okay.
Code
Okay.
mixing of Hindi and English.
Yeah. 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 Okay. That sounds interesting. Yeah. Because
Yes.
the human effects affecting the overall, NLP, I think it's a very interesting topic, and I'm very sure all the participants had a lot to take home about. Any other questions, Anand?
Yeah, we have a question. It's from Adib. Sir, do you really think these machines can replace humans in jobs such as receptionists, waiters, etc.? In short, can these machines bring an end to many jobs?
No, so this is the ethical question. I don't think so, but it will be a supplement. Means it will augment to the human effort. We can reduce the human effort. Okay, but I don't think that it can completely eliminates the humans' interventions. Okay. Maybe the 70% efforts may be reduced, so human can do some kind of risk processing, and they don't have to continuously engage into the conversations. Let's say if you railway reservation, for example, if you are inquiring about certain claims, okay, so this is a very standard questions, right? So that the chatbot should be able to answer. Right? So very standard questions, for example, availability of the claim, the care of the claim, for a particular class of the claim. Okay. But if it is related to some other information, like let's say you have raised a complaint, uh, then complaint is not being addressed to, then that also some sort you can address to the chatbot. But there will be many scenarios where the human's engagement will be important. So I would not say that it is a completely, it will eliminate the human's intervention. It will reduce the effects. So I think
Okay, so
it will be a kind of assistant to the human. Yes.
okay, we have another question. It's from Abhilash. He says, "Thank you. Is it basically more looking at customer support scenarios or advanced support systems like Industry 4.0 scenarios of safety and so on?"
Yes. So it is not for only the customer care scenario. For example, the in customer care scenario, the the work that I have presented, particularly this party assets of the politeness, okay, that was more for the customer. Okay, and that is only for the customer. Yeah? But for example, the knowledge grounding, the introducing the emotions, sentiments, personalization, introducing the multimedia. This is not merely towards the customer care. Okay, it is proper human to human communications. Okay, so you want to converse with a machine, and the machine should be enabled, the power empowered with the humans' ethics and the knowledge. Okay.
Sure. Do we have any more questions?
Okay. So,
Yep.
in case the participants do not have any more questions, I'd like to conclude the session by thanking the speaker, Dr. Asif Iqbal. It's been a pleasure for Computer Society to have hosted you today. Thank you for the wonderful talk, and we hope to continue collaborating with you in the near future, and also more webinars and forthcoming events. And thank you again for your support. And participants, please come back and follow us on our social media channels for the forthcoming events. Thank you.
Okay, thank you very much. Yes, thank you.
Yeah, thank you. Thank you, everyone. The session is officially concluded.
Thank you.